I'm Paul Richardson, Engineering Director here at NM Group. I'm a chartered civil engineer with 28 years of experience in power line design. I'd like to introduce our blog about the evolution of line design, and specifically how the use of LiDAR and PLS CAD has transformed our approach. So what is new line design? What is the difference between optimisation and new line design? So new line optimisation, at its simplest, is the least cost way of building a power line. Line design needs to ensure that all electrical, structural and other requirements are respected. Electrical requirements would typically be the conductor clearance to ground or other objects. Structural requirements that need to be respected might be minimum weight span, maximum weight span, or maximum wind span limitations. There may also be other limitations on structure placement, such as prohibited zones, additional cost zones, or there may be occasions where the landowner or other interested parties express a preference for a particular siting location. Optimisation is achieving those electrical, structural, and other requirements for the minimum possible cost. So what was the original way of doing this? There's a great resource on YouTube where Bonneville Power Administration have produced a video called Stringing and Sagging of a High Voltage Power Line. It's from 1950, and back then it shows the act of profiling or clearing the line. That involved the use of a plastic, or even earlier than that, wooden sag template that allows you to draw in the catenary shape formed by the conductor at the maximum operating temperature. So the designer would assign the required voltage-dependent clearance to all objects within the right-of-way along the line route, and the conductor is then attached to the structures, and those structures are then sized and spaced such that the electrical clearance requirements are met. The structural requirements then need to be checked, the wind and weight span criteria need to be checked for all required conditions, and structure repositioning carried out if necessary. So this siting and sizing of the structure, known as structure spotting, is carried out throughout this vertical alignment. So that's great for utilities, but I'm a contractor, so how does that help me? Well, being able to optimise the line, that allows the minimum construction cost to be determined, minimising the risk that the contracting organisation needs to apply on top of their costs. That means that they're able to reduce the price that they pass on to the client, thereby winning more work. Alternately, they can seek to get an increased return from performing their construction projects. So let's look at the evolution of line optimisation. So a LiDAR dataset for a new line can cover a wide area that would typically be 200 metres wide. Within this swath of data are millions of data points, typically between 20 and 40 points per square metre, and each of these points will be coded and assigned the voltage dependent electrical clearance for that object based upon the local code. Additionally, prohibited zones and additional cost zones and possibly required tower positions may be added into that alignment. And that large swath makes it possible to modify the alignment, to change that vertical alignment centerline where required. So how are the structures represented? Well, a structured database is created where every potential tower family, tower type and tower extension are listed. Each structure will have its external and internal geometry assigned within PLS CAD. This external geometry defines the size and the spacing of the crossarms. The internal geometry defines how far the insulators may be allowed to swing under different weather conditions, normal, high wind, emergency. Each structure will have its structural capacities defined, the minimum and maximum weight spans, and also the maximum wind span. These can be defined as single-sided limits or as total limits. So how are costs represented? And how does the software work out the optimal vertical alignment? Well, every structure variant has a cost assigned to it. This cost can be based upon the steelwork that can be more accurate. accounting for the full bill of quantities costs for each structure type, so steelworks, insulation, fittings and foundations. The software will attempt to cite every single structure type in every single structure location, and it will report back on the structural and clearance status. The software will record the sequence and spacing of structures that meet the structural and electrical requirements, adopt any required tower positions, while rejecting any prohibited zones for the lowest cost. So in conclusion, what do PLS CAD and LiDAR provide? PLS CAD and LiDAR provide unrivaled accuracy in the alignment detail. They allow every single potential structure to be tried in every single potential location and report back on the least cost solution.